And before I start talking about Sailbot, I've been also asked to tell you a little bit about myself. I'm soon to graduate. I've been here for 5 years now, and I'm actually from this place. It's on the other side of the globe. It's a place called Stavanger, and it's in a country called Norway. And I came here 5 years ago from that place, thinking this was a great school and a great place for skiing. So there you go. That's my secret. I've also been asked to talk a little bit why I chose engineering. Actually, I went into science in my first year, and then I went into engineering. I went into an engineering program called Integrated Engineering, which is basically a program where you can kind of shape your own way. So if you're interested in chemical engineering and software engineering, you can do both of them in the same program. Or maybe you want to do mechanical engineering and electrical engineering, you can do it the same way in integrated. So I've used that. I've been in something called co-op, which is like a work program, I guess, at UBC, where you can get to work at companies and kind of try your engineering skills in real life. And I got to work in a couple of different interesting places. The first one, they made this guy. This is a robot, and it's called Robotic Drilling Systems. It's a company that makes, well, robotic drilling systems. So these are robots that in the future will hopefully replace humans for drilling, and they're both exploring potential places like the North Sea, drilling for oil and gas, but they're also working with NASA for drilling in space. That might be interesting. This is another one. I work for a boat design company here in Vancouver called Robot Limited, and there I kind of got to. I've done mechanical and software engineering. So both of these companies have done a little bit of both of those things. And but this one has been a very much like a mechanical engineering basis. And this boat, I actually had 3D model this boat. This is not a real picture. It's a 3D model, and I actually made this 3D model. This is a Russian boat. All right, so over to the main presentation. I'm from UBC Sailbot, and we basically make self-driving sailboats. And we have kind of started a project that we're soon to be completing. And we're going to be sending a robotic sailboat from St. John's, Newfoundland, over to Ireland. So it's going to travel 2,900 kilometers all by itself, us not touching anything. So we're going to be communicating over satellite and sending daily forecasts and stuff like that, but the boat has to kind of go its own route. So it's kind of a very cool little challenge. This is how it looks like. It has kind of the latest in sensor equipment and electronics. It also has a really advanced power system where we, obviously, since it's a sailboat, it's powered by the wind, but the electronics still need energy in terms of electrical energy. And we're actually generating that from some very high quality marine grade flexible solar panels that we got from Italy yesterday actually. So how do we make a sailboat autonomous? Well, it's pretty easy. It's actually artificial intelligence. But unfortunately it doesn't look like this. You guys might not know that joke, but yeah. So it's not AI. We're not taking over the world. So the first thing in making something autonomous is that you have to know what's going on out in the world already, right? What's around in your environment, right? So to do that, well, you have the wind, the sea. So you have to detect that somehow. And what we do is we get weather information sent to our boat, and it can make its route based on that, right? Because weather can also be an obstacle, right? So you don't want to hit the worst kind of weather. You also have something called AIS, which is basically a system where one boat can communicate with another boat, and the other boat can tell our boat like where it's heading, how fast it's going, and what its exact position is. So here you can see, for example, in Vancouver, you can see this This one boat is going at 11 knots and it's heading at 289 degrees, and yeah, that's a really neat system for communicating. A third one we're working on is kind of an interesting one, and it's something that, as far as we know, has never been done before, and it's using thermal imaging to detect obstacles. You guys might know thermal imaging, and it's kind of a video camera, but instead of seeing colors, regular colors, we would see, for example, myself as very red because I have a high heat, while the background would be cold, so it would be blue, right? So that's kind of what thermal imaging is. Here is just a grayscale image. So you can see how you can easily tell living things apart, or things basically with a different temperature than its background. So we're trying to use that to detect obstacles in the ocean. Because as you might think that, the ocean generally has one temperature. It's usually 4 degrees Celsius, at least in the North Atlantic. And while the other things that's floating in the water might not have the 4 degrees Celsius. So for example, an iceberg is very much colder, while a ship might be a lot warmer because it's engines and exhaust and all of that. So we built this guy, and this is basically our little test rig that we took to Tofino. We recorded some whales and some different obstacles that were in Tofino, and we are kind of currently developing an algorithm to detect obstacles based on the thermal imaging aspect, and have that feed into the rest of the boat in terms of this deciding its obstacles. So here's a little video, kind of how it looks like. So this is we shot this video. It's in Tofino, and what's happening here is that let me just play it and you'll see. So what's happening here is that we're coming up towards a buoy, which you can see kind of coming up here. The resolution, as you can see, is really bad. It's because these thermal imaging cameras are pretty like modern technology. So getting this poor resolution, it's $400 for this camera. But if you want to go like more of a regular phone resolution, then you're thinking like many thousands of dollars for those kinds of cameras. But if we can see it on these ones, we can make it a lot cheaper. The difference from the left and the right here is that the right one, we added a horizon line, and it will automatically adjust the image based on the horizon line. So you can see it's actually the exact same image. It's just constantly adjusting to where the boat is going. Right? So it's kind of neat things. And this is all we've all developed this in-house. So this is all our software team has developed. So, and here you can also see how our algorithm is picking up the buoy itself, right, as we're passing by it. So this is some of the technology we hope to use in our vessel. That's another one. This is a kind of interesting one. So here's a little bit of an animation showing you kind of how we detect things, but we eliminate things that might be an error in the image. So say if you're sailing in your boat and you see you have a buoy here, and then the sun is coming in, and the sun glares in the ocean, you might pick up those sun glares on the algorithm, right? So the way we do that is we're kind of like averaging out everything. So as you can see like sun glares coming up here, but in here it's only appearing for a very little bit, while this is constantly being here, right? So that's why it knows that it can disregard all of those. All right. And here's how kind of the algorithm thinks. So as the boat is coming up towards an obstacle, it suddenly sees the obstacle on the video, and then it marks it on the spot of the video. And then as it gets closer, it's taking more and more photos, and then it can accurately pinpoint where that obstacle is. And it's basically the whole algorithm after that is basically seeing how it can get away from that obstacle. So it's just constantly trying to go past it, basically. So once we figure out what there is there in terms of obstacles, you've seen in the environment and you translate it into something that the boat can understand, right? And where the boat can actually do something about it. We're using an algorithm called the A-star algorithm, which is a pretty famous software algorithm for finding the shortest path to a goal. And basically what it does is that it analyzes all of the ways you can get around an object, and it finds the best path, right? So you can see it there as well. Here's an animation that we did, and you can see here that what we've done here is we overlaid wave height. This is in the north, this is in eastern United States. Here's Florida down here. So this is all wave heights, and the darker the blue, the higher the waves. And basically what the boat is trying to do here, virtually, is that it's trying to find the best place from here to here without hitting the highest waves, you know, so basically not hitting the worst weather. And as you can see, as you would imagine, it goes close to the shoreline for as long as it can, and it's trying to basically like cut through the bad weather. We've also seen it where the boat will actually wait until it finds a good weather window before it goes on. So it's pretty good algorithm, this A-star algorithm. Okay, so when we made the route, it comes down to actually controlling the boat itself, you know. And the way we do that is, this is kind of like a little sketch of how the boat actually works. It has a brain, and it's called Raspberry Pi. Some of you guys might be aware of what that is. So that's kind of the brain of the system. That's who decides the route and does all of the fancy stuff, right? And then the brain controls the little arms, and the arms are our like Arduinos, so controlling our motors and getting sensor information. That's an Arduino. Some of you guys might have seen that already. The one we're using is called Arduino Mega. And here's the Raspberry Pi. Some of you guys might have seen this already. It's a $35 computer, and it can do pretty much all of what you've seen in terms of the advanced thermal imaging stuff. So, as you might think that sailing to a point that might be pretty easy, it can't be too hard, but actually it's a little bit more complicated than if you're just using a regular boat that has a propeller and a motor on it. The problem with sailing is that you can't go directly against the wind. So as you can see here, we have to zigzag. That's just the physics of sailing. You can't hit the wind directly because you will get equal pressure on both sides of the sail, and you won't get anywhere. You're basically stuck in one spot. So that's kind of an extra added challenge to this kind of a boat. Another challenge in the marine environment itself is sensors. You need to have pretty good sensors to deal with the salt water, because as you guys might know, electronics don't really like water that much, and especially salt water, they don't like that. So you need to have marine grade housing, but also you want pretty accurate sensors, because this boat is going all over the place, all the time, right? So you need something that's high speed sensors and very accurate. Here's some of our sensors. This, as you can see here, this is actually a GPS antenna, and this is going to be on our new transatlantic vessel. And this GPS itself is quite different than what you would find in a regular phone, for example, a regular commercial grade GPS. It actually has an accuracy down to around 20 centimeters, so it can pinpoint you wherever you are on the globe to within this much, while on a phone it is usually around 10 meters. That obviously comes with a price. So what does all of this mean, right? So why do we do all of this? Well, one part is because it's really awesome, and you probably won't have the time to do this after school, so why not do it while you're in school, and people like UBC actually funds you for it. The other part is that it kind of has some cool future potential, you know, that, you know, as the world, as the climate change is upon us, we might want to think about the environment a little bit more, right? So having solar sails on a big container vessel might not be as distant future after all, right? So we hope to make a little impact on that, right? Also in the autonomous aspect, you have all of these autonomous cars coming out. Google is making some, and Uber is making some, and you can see Intel and Volkswagen, all of Red Bull is apparently on it. I don't know what Red Bull is doing. Yeah. So it's autonomous systems is a big deal, and considering that 95% of all shipping is done by marine shipping, it kind of is a big deal for the marine industry too. So, yeah, that's pretty much it. What I had. You guys can come and talk to me afterwards if you have any questions. Do we have time for questions now, or do we just?